All right, today we're going to talk about graphing quadratic functions written in standard form. So again, a quadratic function in standard form is going to be of the form ax squared plus bx plus c. So we're going to take this in pieces. This first couple examples, we're going to look at just the quadratic term, the ax squared, and then we'll start to add in some of the other pieces. So when graphing this, all we're going to simply do is make a table of values, but what we want to figure out in any sort of graphing of a quadratic function is where is our parabola going to be centered. Remember that all quadratic functions are going to form that U-shaped graph called a parabola, and based on what we talked about in our very first section, that parabola has what's called an axis of symmetry, which is the line that cuts it in half, and also on that axis of symmetry you have what's called the vertex, which would be that central point on the parabola. So our goal is we're going to try and find those two things first in order to make our table of values. To do that, we're going to use the formula of x equals negative b over 2a. So this formula here is used to find, again, our axis of symmetry. So based on my function, I have y equals 2x. So I'm just going to write this up here just so we can, 2x squared. So notice that when I have the function 2x squared and we're only looking at the quadratic term, we are missing the linear term as well as the constant term. Now, if those terms are missing, that means that the b or c value is going to be, in each of these cases, 0. Okay? So in using my axis of symmetry formula, to plug these things in, I have negative 0, or negative b, which is going to be 0, divided by 2 times a, which is also 2. So simplifying that, I would get 0 divided by 4, which is simply 0. Now what that means is that my graph is going to be centered around the point 0. So I'm going to put 0 in the middle of my table. And then what I'm going to do is, knowing that my graph is centered around 0, and heck, I'll show this over here by putting that green dashed line, which represents my axis of symmetry, along 0. What I'm going to do is I'm going to choose some values to the left and to the right of 0. So say, for example, I'm going to choose negative 2, negative 1, and then 1 and 2, so it kind of goes in order. And then now what I'm going to do is I'm going to take each of these values, consider them again as my input, and I'm going to plug them in where x goes. So I'm going to take them and plug them into my function of 2 times x squared, and I'm going to take those inputs and plug them in again into those parentheses to get my outputs. And for my outputs, I get 8, 2, 0, 2, and 8. And again, all of that was by plugging in each of these inputs. You'll notice that centered around 0, 0, so that is going to be the location of my vertex, 0, 0. You'll notice that I have repeating values. I have 2 and 8 on the right side of my vertex and 2 and 8 on the left side. When I graph that, I would have 2 here and then 8 here. Same thing on the right side, 2 and then 8. What it forms is a very tall U-shaped graph. And this is the idea of what it means to be symmetrical or have an axis of symmetry, is that the points on either side of the parabola are going to be identical. The way that I like to look at this is, you'll notice this first point. Notice that it is 1 unit away from the axis of symmetry, and the point, its reflection on the other side, would also be 1 unit away. Up here, this point is 2 units away from the axis of symmetry, and on this side it's also 2 units away from the axis of symmetry. So by understanding where the axis of symmetry is in the vertex, we can then figure out our points, and you're going to see that if you do this correctly, the point should be a repeating pattern on either side of the axis of symmetry. All right, so we're going to follow the same pattern here. Here I have y equals negative 1/2 x squared, so think of this again as the ax squared term. This is a quadratic term. So first thing I want to do is find the axis of symmetry by using my formula, negative b over 2a. Just like the last one, there is no b value here, so that's going to be 0, and a is going to be negative 1/4. Simplifying that, I'm going to get 0 divided by negative 1/2. I know that's within a fraction, but that's going to simplify down to 0. So again, my table is going to be centered around 0. I'm going to have an axis of symmetry on my graph centered around 0. I'm then going to choose points to the left and right of 0, which, just like the last problem, would be negative 2, negative 1, 0, 1, and 2. And I can choose other points, but I'm just going to go in order there. My goal then is to plug each of those values into my function, -1/4. And again, where I see x is where I'm going to plug those things in. And as I do this again, I'm going to plug those values into parentheses. And what you get is your outputs would be -1, -1/4, 0, -1/4, and -1. So again, you're going to see the repeating pattern. Now, obviously, these are not some of the best numbers, but let's see what it looks like on our graph. So -2, -1 would be left 2, down 1. -1 1/4 would be there, 0, 0. I have 1 and -1/4, and then 2 and -1. And what that's going to do, again, is form a U-shaped graph. The only difference here is that you're going to see this U-shaped graph is downward, and you'll notice that's a little bit wider than before. So when we graph a quadratic function, the number in front, which is our a value, is going to determine whether our parabola is going to be up or down. So if a is positive, we're going to have a parabola that's going upward. If we have a negative a value, that's going to be a parabola that's going downward. If our a value is any number that is greater than 1, that means our parabola is going to be very skinny or very tall, if you will. And the last thing is that if my a value is going to be less than 1, okay, so say like a fraction or something, then we're going to have a very wide parabola. So that a value in front is going to control a couple things about my parabola. All right, next thing is we're going to add in, to make this a little simpler again, now we're going to add in a different term. So you'll see here in this function I have y equals x squared minus 2. So if we compare that to any basic quadratic function, ax squared plus bx plus c, you'll notice here that I have the ax term. So I still have the quadratic term. Notice there is no x but just a number, so that's going to be the c term. So think of this as the ax squared plus c part of this, okay? Our way of graphing this is going to be the same. We are still going to use our axis of symmetry formula of -b/2a to find our axis of symmetry and our vertex. In this case, again, our b value is 0 since it's not there. Our a value, the number in front of x squared, would be 1. So 0 divided by 2 times 1, which is 2, should give me 0. And then I'm going to choose values around 0, which again I'm going to use -2 to 2. Just as a side note, it's not always going to be like this, but just in these examples it is. And then my goal now is to take that value of x and now plug it in to my function where I see the x. So again, it would be 1x squared. So instead of the x, I'm going to put in parentheses my inputs of -2 to +2. And what I would get is 2, -1, -2, -1, and 2 as my outputs. So again, my axis of symmetry I'll show it here is still centered around 0. You'll notice a slight difference here is that my vertex is no longer at 0, 0, but now it's shifted down 2. And then if I were to draw my points on the either side, I would -1, -1, and then -2, 2. And then same thing on the other side. My points are identical to form my U-shaped graph. You'll notice here that my graph, which in the previous two examples was centered at the origin of my graph, and now you'll see it shifted down 2. So you'll see here we have -2 added on, that the c value is going to shift the graph up. So it's going to shift it upward, or it's going to shift it downward depending on if that value is positive or negative. All right, so let's try this example. I have -1/2 x squared plus 2. So notice here we have, again, the ax squared term, which is my quadratic term, and then the plus c. So using my axis of symmetry formula is how we're always going to start here. My b value would be 0 again, and then it's 2 times -1/2. I'm going to get 0 divided by -1, which is 0. So again, my graph is going to be centered around 0, just like we've done in the previous few examples. And my goal then would be to plug my values of x's, my inputs, into my function where I see x. I'm going to plug them in here into the parentheses, and I'm going to get my outputs again for this specific function. And what I'm going to get for my outputs are 0, 1.5, 2, 1.5, and 0. So 1.5 I'm getting as 3/2. So my axis of symmetry is going to again be centered at 0, as I'm seeing here as the middle of my table again. All right, now plotting the points, my vertex is going to be found at 0, 2. So notice it shifted up 2 because my C value was plus 2 here. Then plotting my other points, I would have negative 2, 0, negative 1, and then 1.5. And then the same points on the other side to form my U shape. And again, you'll notice it's upside down and a little bit wider. And that's because I have a negative 1/2 in front. That A value is going to flip it upside down as well as make the parabola a smidge wider. All right, last two examples here. Now we're going to do the full picture. So I have my quadratic function again, y equals ax squared plus bx plus c. So notice I have all three terms here. 3x squared would be my quadratic term, minus 6x would be my linear term, and plus 5 would be my constant term. I'm going to graph this the exact same way. Negative b over 2a, I'm going to use my axis of symmetry. All right, now that we have a b value, notice my b value here is negative 6. So now when I plug this in, the negative b means I want the opposite of negative 6, which means I want positive 6. Divided by 2 times a, which a is 3. So simplifying that, I'm going to get 6 divided by 6, which is 1. So notice now I'm not getting my points centered around 0, but now it's centered around 1. So my axis of symmetry is going to be shifted to the right 1. I'll draw that green line here. Again, that's my axis of symmetry. I then want to choose values centered not around 0 anymore, but around 1. So let's say 2 and 3, and then 0, negative 1. On my graph, you can see here, 1, 2, 3, 1, 0, negative 1. I'm going to follow the same process of then plugging those inputs in. However, there's a little bit more involved here. I have 3x squared. So I'm going to take those inputs and plug them in right here where I see x. But now I have minus 6x. So I have a second spot where I need to plug those numbers in, and then I have the plus 5. So for example, if I were to plug in my first input of negative 1, I'm going to plug negative 1 into the spot we were plugging in before. But because I have a second x in this function, I'm going to plug it also in here. So every input is being plugged in twice. Okay, and then we're going to evaluate each of those for our given outputs. And what I would get is 14, 5, 2, 5, and 14. So to start to plot this, I'm going to start with my vertex would be at 1 and 2. So now it's shifted up 2 as well as right 1. I would then have 2, 5. So I'm going to have 5 on both sides. And that would be at 0, 5 as well. And then I would have negative 1, 14 and 3, 14. Now my graph only goes to 10, so 14 would be all the way up, way above 10, all the way up somewhere right there. So again, what I'm going to get is a very skinny parabola that goes upward. Okay? So what we have is not only we have a couple things, like the 3 is going to tell me again it's going to be very skinny. We said the 5 is going to shift it up. But then this minus 6 is also going to shift the location of the vertex. It's no longer at 0 anymore, but it changed to a spot of 1, 2. All right? So we follow the same process. Our graph is just going to be moved around a little bit when we have the full quadratic function. All right, last example here, I have negative 5x squared minus 10x minus 2. Again, I have all three parts to this. So I have my quadratic term, my linear term, and my constant term. First thing I want to do is I want to use my axis of symmetry formula to figure out where my graph is centered. Here my b value is negative 10. My a value is negative 5. So I would have the opposite, which is positive 10 over 2 times negative 5. That's going to be 10 over negative 10, which means here my graph is going to be centered around negative 1. Drawing this on my graph, negative 1 would be shifted 1 over here. Again, it could be shifted anywhere on my graph, in this case shifted 1. What I then need to do is choose other values in my table that are centered around negative 1. So let's say I go negative 2 and negative 3 on the left side, and then 0 and positive 1 on the right side. And again, all I'm doing is looking at my graph. Here are some values on the left side, some values on the right side. My goal then would be to plug each of these inputs into my function. So I have y equals negative 5. And then I have the x squared, so I'm plugging in that input first into there. And then I have minus 10x. So again, I'm going to plug my input into the second location as well. And then finally, minus 2. So I'm going to plug all of my inputs into both spots each time to get my outputs. And the outputs I would get would be negative 17, negative 2, 3, negative 2, and negative 17. So plotting these points, I'm going to start with my vertex would be left 1 and then up 3. And then plot my other points, so I'd have -2, -2. I have on the other side 0, -2, so again, oops, same point on either side. And then I would have -3, -17, so that's going to be all the way down here, way off my graph. And the same thing on the other side, 1, -17. So if I were having enough room, I would have a parabola that's going to be very skinny and downward. Okay, and again, each of these things, the -5 is going to flip it upside down and make it very skinny. The -2 is going to shift it, and then we also have that b value that's thrown in. All right, so this was graphing quadratic functions in standard form. So again, the process was figuring out our axis of symmetry first, and then just using the idea of inputs and outputs, plugging things in and getting things out to get our U-shaped graph. Got any questions? Make sure you jot those things down. We'll see you guys next time.